Now let's solve the validate binary search tree problem on LeetCode. This problem is classified as medium. Given the root of a binary tree, determine if it is a valid binary search tree, BST. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys strictly less than the node's key. The right subtree of a node contains only nodes with keys strictly greater than the node's key. Both the left and right subtrees must also be binary search trees. In example 1, we have node 2. In order for this to be a valid BST, the values to the left of 2 must be less than 2, and the values to the right of 2 must be greater than 2. In this case, to the left of 2 we have 1, and to the right of 2 we have 3, therefore this is a valid tree. If we take a look at example 2, the values to the left of 5 should be less than 5, 1, which is correct, and the values to the right of 5 should be greater than 5. In this case it's 4, which is false. Therefore this is not a valid BST. One point I'd like to stress on is they mentioned that both the left and right subtrees must also be binary search trees. In other words, what they're saying is that 4, 3, and 6 should also be a valid BST. Although this is a invalid BST, let's go ahead and check this subtree. So the values to the left of 4 should be less than 4, 3, which they are, and values to the right of 4 should be greater than 4, 6, which they are. One more thing I want to mention is that the BST applies to the entire tree. So what I mean is that to the right of 5, all the values within the subtrees to the right of 5 should also be greater than 5, and all the subtrees to the left of 5 should include values less than 5. Now the way we're going to solve this is through recursion, like with most tree problems. And of course, through recursion, we're going to need some base cases. But the approach that we're going to take is the following. We're going to create a helper method which takes 3 inputs: the node which we're currently on, a minimum value, and a maximum value. These min values and max values are initially going to be initialized to be null, and we're going to continuously update them as we go throughout the tree. We're going to update min and max to be the values that we want to compare, and if the conditions which we're checking are not met, then we're going to return false. Now this is a bit vague, but let's go ahead and start coding to really understand what we're going to do. So like I said, first and foremost, this is recursion, so we're going to create a helper method which we're going to call in itself, and we need some base cases. So first and foremost, we're going to return a boolean, so public boolean. Let's call this confirm BST, which takes 3 inputs: a node, a min value, or an integer min, and an integer max. And the reason why we're using integer and not int is because we want to initially, like I said, initialize them to be null, and null is not of type int, but integer would work in Java. So what's our base case going to be? Well, if we're scanning throughout the tree and eventually we reach a null node, we're just going to return true. So let's go ahead and do that. If node is equal, oh, I forgot to include node here. So if node is equal to null, then return true. The reason why we use this as our base case, if node is equal to null, return true, is because if we had an empty tree, no nodes at all, then this tree is automatically valid because it does not break the BST property. So if we reach a node which is null, that means we went through the entire tree and we did not break the BST property, so we're going to return true. So now what we're going to do is we're going to check 2 conditions. The first one, we are going to say if min is not equal to null, which it initially is, and min is greater than or equal to node.val, what are we going to return? False. And if max is not equal to null and max is less than or equal to node.val, then we're going to return false. So this is where recursion comes to play. What we're going to do now is we're going to return the result of the method that we just created, but we're going to be updating its parameters. So here we have to go left and right in our trees. Instead of node, let's go left first. So instead of node, we're going to check our left node now. And now we need to replace our parameters for minimum and maximum. Since we're scanning the left part of our subtree, and values to the left should be less than the node that came before it, that would mean max should be node.val, which is the node that we're currently on. So let's write that, node.val. That's our max value. And we'll keep min as it is for now. And then we're going to put another condition. So and confirm BST. But instead of checking the left side, we need to now check the right side. So node dot right. And since values on the right should be greater than the node that we're on, our minimum value will now be node dot val, and we'll keep max as it is. So to explain a little why we used and, since we're returning Boolean, we need to confirm that the left side of our tree, our left subtree, is all true, and we need to confirm the right, our right subtree is all true. But if one of them was true and the other was false, then this isn't a valid BST, and we're going to return false. So the only way we'd return true is if both our left subtree is true and our right subtree is true. So before submitting, also we need to return up here confirm BST, which takes the inputs root, and then like I said, we're gonna initiate them to be our min and max to be null initial. So now let's go through example 1 to see what we wrote and if our code works. Okay, so post editing, I kind of realized that I didn't really go through the example very well. Also, we had a syntax error here. I misspelled confirm, so I fixed that. But I would like to go through the example again just to make sure we get the point across. So let's go ahead and do that now. So initially what we do is in our method above, we return confirm BST, which takes the root, which is 2, and then null and null. Then we're going to call our helper method. Once again, the first call is going to look like this, confirm BST, which takes 2, null, and null. And so what's going to happen in our first call is our node null. It's not, it's equal to 2. So we're going to move on. And since initially our min and max values are null, we're going to skip these 2 blocks of statement, and we're going to go directly here. So therefore, confirm BST with 2, null, and null is going to return the result of this. Now here we're going to update our values. So initially we're on 2. We're going to check our left subtree, so node.left. We're going to check our node on the left. So node.left is now 1. We're not going to update min, but our node.val is 2. That's the value of 2. And then confirm BST. Now we're going to check the right subtree. So node.right is 3. Our node.val is 2, and we're not going to update max. So both of them are actually equals to null. The reason why I changed, so obviously node becomes node.left because I want to check my next node. Similarly for node.right. And then our node.val, within this statement, our node.val is max because on the left subtree these values cannot exceed a max value, which is 2. And on the right side, our minimum value is 2 because our values on the right should exceed the minimum value, or the node which we're currently on, which is 2. So now we're going to return the result of these 2 statements. So let's first take a look at this. Okay, so what happens here? Well, we're going to check if our node is null. Is 1 null? It's not. Our min value is still null, so we're going to skip this. However, our max is now 2. So what we're going to do is we're going to check if our max value is less than the node.val, the value of the node which we're on. Because if our max value is less, then our tree is invalid, and we're going to return false. So is 2 less than or equal to 1? It's not less than, so we're good. We can move on. And we're gonna call this statement now. So let's go ahead and do that again. So now we're gonna update our pointers again. So node.left is now null, to the left of 1 is null. We're not changing min, and node.val is 1, so actually this is also null. And then confirm BST on the right, so we're gonna check the right of 1, which is also null, and node.val is 1, and max is also null. So let's check out this statement first. Return confirm BST null, null, and 1. Is node equal to null? Yes, so return true, so we can just remove this. And we know that this is going to return true, so we can just replace this with true. Similarly, if we check this, we're going to see that node is equal to null, so return true, so we can also remove this. So this is also true. True and true, that's true, and therefore we know that this is true. Okay, now we can move on to our next, or the right subtree. So let's take this and now study the other tree. So we're here. Is 3 null? It's not, so move on. Is min equal to null? No, it's actually equal to 2, so we're gonna check if our minimum value, which is 2, is greater than or equal to node.val. Since 2 is not greater than 3, we can move on, and max is equal to null, so we can skip this. Now we're gonna return this entire statement, so let's go ahead and do that, but we're gonna update our values. So node.left to the left of 3 is null, minimum is also null, and then node.val is 3. And then we're gonna check the right, or to the right of 3, so that's null as well. Node.val is 3, and max would be 3. So let's check out what this statement, so if we actually check out what this statement returns, we're gonna see that null is equal to null, so we need to return true. And then similarly here, we're also gonna return true. So true and true, that's true. And we can just replace this with true. Since true and true again is true, so we're just going to return true. Therefore, our tree is valid. Okay, perfect. So I hope you found that video helpful, and thanks for watching.